Welcome back, everybody. This is going to be part 2 of 3 in my series on the principles of counting. If you haven't watched the first one, please go and watch it now, as you're going to need it for this one, because in this video, we're going to talk about permutations. Let's get started. A permutation is simply just a unique arrangement of a group of objects. And by the way, we're assuming here that no one item is repeated and that the order of the arrangement matters. And it turns out that this is the way that we calculate the number of permutations we can make. So if we've got n objects total and I'm taking r of them, right, and I'm forming a permutation of r out of n objects, we write npr. By the way, we read this as n pick r. So I'm picking r objects out of a list of n. And it turns out that this is the way we compute those. Quick refresher, in case it's been a while. This exclamation mark here is what we call a factorial. That's what we call a factorial. And to take a factorial, for example, if I have 4 factorial, I take 4 times 3 times 2 times 1, right? Or I just count down until I get to 1 and multiply them all together. So let's get a quick practice in with how to use this formula. And let's compute 6 pick 3. Well, the left number is the number of objects total. That's the number that goes on top. So I get 6 factorial on top. And on bottom, I get 6 minus 3. Notice the parentheses, factorial. So I need to obey my order of operations. This is 6 factorial over 3 factorial. Now the factorials look really scary, but they're actually kind of nice because of how much cancellation goes on when using these problems. So notice in the top, I've got 6 times 5 times 4 times 3 times 2 times 1. And in the denominator, I've just got 3 times 2 times 1. So I have a lot of factors that cancel top and bottom. I've got a 3, a 2, and a 1. And all I'm left over with here is 6 times 5 times 4, which is 120. Now that we've got some practice with how to compute permutations, let's do a problem. A company has 10 members in its board of directors. How many ways can they elect a president, vice president, secretary, and treasurer? Notice that the order in this situation matters, which suggests I need to use a permutation as opposed to a combination, which we'll see in the next video, because I can't have any one person serving multiple roles. So I've got a group of 10 people, and from them I need to pick 4 to assign to these unique roles, and the order in which I assign them matters. Go ahead and pause the video here to see if you can finish it on your own. I found 5,040 ways. Feel free to pause the video here to check over my work. In this video, we saw how to compute permutations, which are sort of an extension of that principle of counting. In the next video, we're going to learn about combinations, which is how do I pick r things out of a group of n objects, but this time it doesn't matter what order. Catch y'all in the next one.